Okay, welcome back, Bacho. I was telling you about the possibility diagrams while giving you a recap of your O-level probability. Okay, so the possibility diagrams, and we have just uh, gone through the table diagram very briefly. Okay, my purpose was to make you recall that table diagram, that how do we draw that. Okay, now we have the tree diagrams. Now this tree diagram can be made in any of the cases, like um, but there are, let me first tell you that how do we draw this, and then I'll tell you those two typical cases that we consider before we start drawing these tree diagrams. Okay. Now, first of all, you must not be going for a tree diagram for a case when you are tossing or throwing a die twice. Because you see, what happens is, let me tell you how we draw a tree diagram when a coin is being tossed twice. So first of all, you have the number of branches depends on the number of outcomes of that particular experiment. So if you know that you're going to toss a coin and there are going to be two outcomes, this is head or tail. So you will have two branches here, okay? And then you go into the second experiment. If the first coin is showing a head and you're going to toss this coin again, the second coin can show a head or a tail. Okay. If the first coin has shown a tail, the second coin can show a head or a tail. Okay, so that is how there are four outcomes of this experiment. That means they are both showing the head. The first is showing a head, the second is showing a tail. The first one is showing a tail, the second one is showing a head, and both of them are showing the tails. Okay, so this is your sample space for the situation where you are drawing um, sorry, where you're tossing a coin twice. Okay, it is really good. It is really helpful if you write the probabilities of these events on these branches. Like when you toss a coin, you know that the probability of getting a head is 1 over 2. And for the tail, it is also 1 over 2. For the head, it is 1 over 2. For the tail, it is 1 over 2. For the head, again, it is 1 over 2. And for the tail, it is 1 over 2. When you write these probabilities onto these branches, you have to make sure, this is very important, Bacho, and there are many, many questions where the examiner tests this thing, okay? So you need to note it down. You have done this already as well. The sum of the probabilities of on these branches should always be equal to 1. You will be getting questions where you will have blah, 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 blah. This is A, this is 0.2, and this is 0.4, let's say. So you will have to find the value of A. So there you have to remember that, oh yes, the sum of the probabilities on all these branches, that is going to be equal to 1. So that is how you can determine this value of A. Okay, so remember, whenever you are drawing a tree diagram, you must have the sum of the probabilities on these branches. Okay, now when we say the sum, so you people are not going to add all these four probabilities here. Okay, this is not the way to do it. You just take this is a tree over here, there are two branches onto it. This is like, you know, there are two branches over here. Okay, so these sums should always be equal to 1. Okay, and in fact, I forgot to tell you when I was telling you about this formula, that I should tell you now that probability of A is n of A over n of B. And there you have probability of A plus probability of A dash. that is always equal to 1. And there is one more rule, that the probability of A is always between 0 and 1. So these are the key points that you need to remember, okay? Um, can you have a probability which is 2 or 200 or 300? Yes, Bacho? Hmm?
No, sir.
No, sir.
Anna? And similarly, probability cannot be negative as well. If something is not going to happen, the probability is going to 0. And if something is going to happen at any cost, so which is going to happen definitely, so the probability there is going to be 1. Okay. So if there is a there is a, I don't want to go into that detail, there are the terms like it is um, likely, less likely, more likely. Okay. Less likely is a situation when you have the probability which is normally the probability is between 0 and 1. Okay, so if the probability is in this region, so that means it is less likely. If it is going to be in this region, so that means this is going to be more likely. Okay, and then there is the term equally likely. Okay, so that means if this is equally likely can be used for example, you have three dresses. One is red, one is green, one is pink, and you have to go into a function. So you are going it is equally likely that you wear any of these three dresses. So this would be probability 1 over 3. This is probability is it is 1 over 3. This is going to be 1 over 3. Okay. And I'll come back to this tree diagram, but so there are some terms that I forgot to tell when I was giving you the very basics of the probability. Okay, there was the I there was a spinner I had drawn here, and do you remember what terms did I write on the corner there? Hmm? Um, let's say
1, 2, 3, 4, 5.
yeah, no, this was let me write A B C D here, but I wrote something here in this corner. I want you to recall that. What did I
Sir,
write?
biased.
Yeah, very good. Okay. Uh, Now, suppose if this is a spinner over here, okay, and we spin this, so do you think this is a fair trial or an unbiased trial? Hmm? Yes, Bachu? What do you say about this? You must be knowing about these terms, the biased or the unbiased thing. Hmm?
Sir, it is biased.
How do you say that?
क्योंकि the sizes of जिसके ऊपर letters लिखे हुए are unequal.
Yeah, the areas of these sectors which have these different letters, they are not same. If suppose all the areas were same, then this was going to be an unbiased trial, okay, or a fair trial. And if in this case, this is a biased situation. When I was teaching the probability through the O levels, there is an incident that I always used to tell my students, and I will tell this to you as well. Okay, I remember when we were in the city school that there was late 90s. During the break, I think there were 4 5 male teachers, and we planned that okay, every there are 5 days in a week, so every day one of us would be paying for the canteen or whatever. Okay. Now, one of our colleagues, that was a very conjuice banda, was very miser, okay? He would never pay for the canteen, and he would rather, slip off that day when it was his turn. So we decided that rather than paying turn by turn, we shall be doing a draw every time, okay? We had 5 chits with the names of us on that, okay? And it was decided that every day we shall just pick one of the cards, okay, one of the chits, and whoever's name turns out to be there, that person, that man will pay for all of us, okay. Now, what was happening now in the first day? It was that person's, like, I'm just going to take his first letter. M's name was, like, came out on the chit, okay? He paid very reluctantly. Okay, and on the next day, again, the letter M appeared to be on the chits, okay? And he again, like, he was very unhappy that what is happening. He had to pay for 2 consecutive days. On the third day, he was also a math teacher, by the way. When I was going to pick the chit, he said, "Oh, okay, stop. Let me check the chits first of all." You know what was on the chits? Guess. You can guess it very easily. Hmm? Yes, any of
Sir,
you?
all of them were his name.
Yeah, all of them had the letter M on the chits because we really wanted to, like, I especially really wanted to, like, give him some lesson or maybe tough time, or I wanted him to spend some money. So you see that is an example of an unbiased experiment where, like, we were 5 people, but what was the probability for my name to be coming out in this case?
Sir, 0.
It is 0. And what is the probability of getting the letter M on the chits?
1.
That is 1. Okay, this is just like if you have a die and all the sides are printed 6. So every time you throw that die, the die is going to show a 6. So that is an unbiased situation. Okay, so a biased situation where all the outcomes, they are not equally likely. They are not equally likely to happen. Okay, so that is a biased or an unfair experiment. Okay, I'm going to go back to the tree diagram. There were really some terms that I wanted you to recall. By the way, you have done all of this in your O levels. Okay, so to cover this, you must take these notes. Okay, अच्छा बच्चों, फिलहाल can you tell me, yes, what is the probability of getting both the heads when, like, come back to this situation, to this tree diagram here. You have tossed the coin twice, so what is the probability of getting 2 heads here?
1/4.
That is 1 over 4. Okay, this is 1 over 4. And if you see that if you multiply these two together, it is also going to be 1 over 4. Okay, so this is just to reassure that probability of A and B, there is going to be probability of A times probability of B. Okay, what is the probability? Like, if you look at this, probability of getting one head, one tail. So this is going to be, these two would be out of these 4. So probability of getting one head, one tail is going to be 2 over 4, or you can simplify this to 1 over 2. You can also find it from here, like, you can say probability of one head and one tail is going to be probability of head tail plus the probability of tail head. Okay, so probability of head tail, like, this one here, head tail, this event here, okay, that is going to be half into half. Okay, and then probability of tail and head, there is also going to be half times half. So this is 1 over 4 plus 1 over 4. That gives you 2 over 4. And this is going to be equal to 1 over 2. So you see that these two answers are same here. This one and this one. Both of these two answers are same. Okay, so from this you can note it down that probability of A or B, that can be written as probability of A plus probability of B. Now you have to be very careful about this probability of A or B, because in your O levels, we don't take you into the very detail of this probability of A or B. Okay, this probability of A or B may not be always, this may or may be equal to probability of A plus probability of B. If this happens to be the case, if you see that the probability of A or B is really equal to the probability of A plus probability of B, bacho, so this would mean that these are two mutually exclusive events. So another new term for you people, mutually exclusive events. Okay. I have talked about two terms of your A-level probability. One is the independent events. One is the independent events, okay? That is if probability of A and B is same as probability of A times the probability of B, it means there are two independent events, okay? And the second thing I have talked about, that is the mutually exclusive events. We shall be going into its detail later. Mutually exclusive events, okay? So that is going to be if you have probability of A or B, that is equal to probability of A plus probability of B. Okay, in this case there is also a second condition. So if any of these two conditions is being satisfied, that means the events are mutually exclusive events. So that is if probability of A and B that is equal to 0. Let me give you an example. Suppose there is a situation that you have like numbers from 1 to 10, okay. One set has got the even numbers, the other set has got the odd numbers. So um, you have here 2, 4, 6, 8, 10. You have 1, 3, 5, 7 and 9. Okay, what is the set A intersection B over here? What is this set here?
There's a null set.
Yeah, this is an empty set. Okay, so what is n of A intersection B? That is 0. Okay, and please remember this A and B also means A intersection B. That means like both the things are happening here. Probability of A and B, it's the same, okay? So you see that if I ask that, okay, I have the numbers from 1 to 10, okay? And the set A has all the even numbers, the set B has all the odd numbers. What is the probability of having both even and odd numbers? So obviously a number can either be even or odd. So it is 0 over here. Okay. So this means this is these two sets are mutually exclusive events. Okay. How can this thing be satisfied over here? Now, what is the set A union B? A union B is going to be 1, 2, 3, 4, 5 till 10. Yes. So what is n of A union B, bacho? That is 10.
10.
This, yeah, you have studied this in your sets. Okay. So probability of A separately is going to be 5 out of 10. And the probability of B separately is going to be 5 out of 10 as well. And what is probability of A union B? So that is going to be 10 out of 10. So do you think this condition is being satisfied here? Do you see that this thing happening here, this probability of A union B is same as the probability of A plus probability of B? Yes, Bacho? Come on, yaar, beta. Is this confusing, difficult? Let me know. I can explain you again. Hmm? Can you see this? Let me give you another example now. Suppose you have a set of prime numbers and a set of even numbers, okay? Out of 10, this is A. Now, these are the prime numbers here. This is 2, 3, 5, 7. And these are the even numbers here, okay? So the even numbers are going to be 4, 6, 8, 10. And you will be having some numbers outside here. 1, 2, 3, 4, 5, 6, 7, and 9 over here, okay? So what is the probability of A and B over here? But you tell me quickly. Or otherwise, if there's someone who are not getting this, what is the set A intersection B? This is 2 here. बच्चों बोलो ना यार. This is all your O-level maths. Come on, the time the class is getting
जी
over.
सर 2 है.
And then what is N of A intersection B? That is 1. So what is the probability of A intersection B? That is 1 over 10. Okay? So since this is not equal to 0, there is something common in them. So A and B are not mutually exclusive events. Okay? When there are two mutually exclusive events, the probability of A and B has to be equal to 0. Now, who would like to prove that this probability of A union B in this case is not equal to probability of A plus probability of B? What is A union B? Hmm? That is 2, 3, 4, 5, 6, 7, 8, and 10. Okay. So what is the N of A union B, bacho? That is 8. So what should be the probability of A union B? That is 8 out of 10. So this is 8 out of 10. Now, who will tell me what is the probability of A? How many members are there in A? 1, 2, 3, 4. This is 4 over 10. And what is the N of B? 1, 2, 3, 4, 5. This is 5 over 10. So are these two sides equal to each other?
No sir.
No, sir. Okay, so that means A and B are not mutually exclusive events. So I have, in short, given you a little bit about the independent events and the mutually exclusive events. Okay. So basically, in this segment, I wanted you people to recall the possibility diagrams, the table diagram, and the tree diagram. Okay. Now, in the next class, we shall formally start the A-level probability. Okay. Thank you very much.